Hello friends, this is part 3 of question paper solution. Question paper, this C-10 paper of degree fourth semester, BSc fourth semester, Dibrugarh University, 2023. Paper name is Analog Systems and Applications. Before we start, please subscribe the channel. Also hit the thumbs up button. Okay, and inspire me to create new contents for you, help me to grow my channel. I have provided the links of part 1 and part 2 in the description box. Okay, if you want to watch them, then you can go through. Okay, so here you see, in the last video we have solved these 3 questions of question number 2, this one and this one and this one. So I think I left this question, so let us start with this. Okay, so this is my Insta ID. If you want to follow me, you can follow me. Oza Lekajit 123, right? 123. This is the Insta ID. If you want to follow me, then you can follow me. So now let's start. So discuss different types of PN junction diodes on the basis of the method of fabrication. On the basis of the method of fabrication, so we get 4 types of PN junction diode. That's ground junction diode, diffusion junction diode, alloy junction diode, and epitaxial growth junction diode. And I'm not gonna explain this. Just I have given you the answer. So what you can write, so you can write this lines about this ground junction diode, pause the video and take the screenshot. And about alloy junction diode, you can write these lines and pause the video and take the screenshot and apply the same method to copy this one as well. And next one is epitaxial growth junction diode, right? So then what is the next question number, this is the last one, point contact junction diode. And pause the video and note this. Okay, and next question, draw the circuit diagram of full wave rectifier and calculate its ripple factor. So now let's draw the full wave rectifier diagram. Okay, so this is the diagram of full wave rectifier. Here you see this is primary coil, this is the primary coil, and here we have the secondary coil, and we have 2 diodes, D1 and D2. These are PN junction diodes. So here input voltage V in, and here we're gonna have output voltage V out, and here input voltage versus time graph, and we're gonna draw the input voltage and time graph here, and here we're gonna draw the output voltage versus time graph. Okay, so now let's start. Here you see, suppose we have taken this direction as positive, so this is the direction of current. Suppose now this is let me take positive cycle. So this is the direction of current, then the direction of current in the upper loop will be in this direction, in this way. So from here you see it is P to N, so it is in forward biased. So for this current, the direction of current through this resistance will be in this way. So let me take this as positive direction. Okay, for this positive half cycle, and the next half cycle, this is the negative. Then now the direction of the current will be in this direction, in opposite direction, so which we have taken negative here. So in that case, then what will happen, so let me clean it. In that case, current in the lower loop, so just wait, one more thing, just when you see here, this current in the upper loop is in this direction, which is in forward bias, and at the same time current in this lower loop will be in this direction, and now it is in reverse bias, so it doesn't work in reverse bias. Okay, it doesn't allow the current to it doesn't let the current to pass through it. Okay, so now similarly this is PN junction. Now let us take the opposite situation. Here you see, this is the direction of current. This time suppose this is secondary coil, this is the direction of current. In that case, here you see, let me write this one. In that case, for the red one, if this is the direction for the negative half cycle, then the direction of current in the upper loop will be in this way, right, in this direction, which is in this upper D1, which is upper PN junction, is now in reverse biased, and the lower one will be, the direction of the current will be in this direction. Now lower diode is in forward bias. So now in this time, this upper one doesn't let the current pass through it. Okay, so now in this case also you can see the current will be in the same direction, in the positive direction. That's why we can draw the graph for V in versus time this way. For positive and negative half cycle, the output is, we are getting the output in the same direction. That's why both positive, right? That's how we can write the output and input voltage graph, right? So hope you have understood this. Now let's calculate the ripple factor. Now let us calculate the ripple factor. So ripple factor, that is given by root over IRMS by IDC whole square minus 1. Okay, so here remember one thing, that IRMS, that is equal to 1 by root 2 times of maximum current, and IDC is the 2 by pi times of maximum current, right? Now let's use these two values here. Just wait. This is suppose 1. Putting these values in 1, what we're gonna have, ripple factor, and that's gonna be equal to pi by I naught by root 2 pi by root 2 whole square minus 1. That's what we're gonna have. Sorry, I made a mistake. That's supposed to be 2 I naught times by pi, right? So this is square whole square minus 1. So here you can see clearly I naught cancels. So what we're gonna get here now, so it's gonna be equal to pi by 2 root 2 whole square minus 1, and that's gonna be equal to pi square by 8 minus 1. And if you put the value of pi and if you calculate it, so its value gonna be approximately equal to 0.482, right? So this is the ripple factor of full wave rectifier. So hope you have understood this. So our next question is 3B. Here you see, write about the working and construction of photodiode. So here you see, this is the working of photodiode. So I have given notes here. Just take the screenshot, or you may just pause the video and you can note it. And this is the working ends here, and the construction is this one. So take the screenshot. Okay, so it ends here, right? So So in the next video we're gonna solve from question number 4. Thank you for watching. See you in the next video. Take care.